Hello, I am William Rock and I'm a Senior Applications Engineer here at Headwell Photonics, and today I'm going to go over the assembly of an MV.X along with a scaffolding and a mini mover to enable you to simulate a factory environment and allow you to collect data so you can develop models for your MV.X. So the first thing that I'm going to set up is the scaffolding, but first I'm going to go over all of the items on the table. We have the scaffold here and the light source adapter. We have the MV.X here itself and the MV.X's power supply. We have the light source and its power supply. We have various tools, a white reference, clips to allow you to take the cover off the MV.X without it falling, and a focus target that also allows you to set the speed of the stage properly. And I will go over the usage of all of these things throughout the video. So the first step in setting up your scaffolding, of course, after placing your mini mover in an appropriate location, is to assemble the scaffolding. So the scaffolding comes nice and folded up like this, and if you just loosen the knobs at the bottom, it will enable you to put out the stand. And then once you have the stand out, you just make sure that it is standing up straight and retighten the knobs at the bottom. Then the scaffolding can just be slid under the mini mover and screwed into place using these other knobs on the back of the scaffolding. And this locks the scaffolding in the proper location on the mini mover. The next step is to attach the MV.X to the scaffolding. First, I'm just going to talk about the scaffolding for 1 second. The scaffolding has these 4 knobs that allow you to adjust the height of the MV.X above the mini mover. So if these 4 knobs are loosened, the scaffolding can easily slide down and up. Another feature of this scaffolding is the extra height bar. And this enables you to get a lot of height above the mini mover in case you have applications that require a very wide field of view. So to gain this extra height, you simply flip this up, lock it back into place, and then you have to unscrew the knob that allows you to attach the MV.X and flip it to the other side. In today's video, I will be installing the MV.X in the standard location, so I'm not going to go through the rest of this. So the rest of it is exactly like assembling the MV.X in its standard location. So I'm going to undo the knob right now, put it back in its standard location, and continue with the setup. So now it's time to attach the MV.X to the scaffolding. Here is the MV.X along with its IP-rated enclosure, and on one side of the MV.X you have an extra mounting bracket, and this is what you must mount to the scaffolding. So there are a couple different locations where you can mount the MV.X to the scaffolding, again allowing you some more play in the exact height. The MV.X comes pre-focused to the lower position, so if you want to take advantage of the pre-focusing, please install the MV.X in the lower position. So here I am simply tightening the MV.X and ensuring that everything is nice and level. And voila, we have attached the MV.X to the scaffolding. And as you can see on the side here, there are a couple of stops put into place. So if I, again, undo the tightening knobs on the rail of the scaffolding, when I slide the scaffolding all the way up to the stops, the MV.X has been pre-focused to this location. Now the next step is installing the light source on the scaffolding. So you will need the light source assembly knob and the light source Allen key. Again, for the pre-installed case, it is best to install the light source at the bottom of the rail. So simply slide this into the bottom of the rail and tighten. Now we can slide the light source itself into place. And approximately line it up with the MV.X window. And it actually is lined up quite nicely if the end of the mount is flush with the end of the rod. So that's a nice, easy set point that can allow you to center the light source on the mini mover. So now the next step is to plug everything in. So we can take the light source power supply, and the light source power supply has already been plugged in, the cord has already been plugged into the power supply. And I'm just going to wind it through the scaffolding to keep things out of the way. And on the other side, this 90 degrees is pointed toward the MV.X when it's installed properly. And if you look very close, there's a little mark in there that needs to be lined up with the same mark on the light source. And again, if this 90-degree elbow is pointed toward the MV.X, they will be lined up properly. And it's very important to line them up properly, because if they are not lined up, you won't be able to tighten it all the way. And it needs to be tightened all the way in order for the light source to turn on. And when it is tightened all the way, you will not see any of the black retaining ring at the bottom anymore. And finally, the last step is just plugging in your MV.X. And so now again, I'm going to wind the power cable through the scaffolding just to keep it out of the way. And again, I'm going to line up the notch on the power supply with the notch on the MV.X, plug it in, and then screw it into place. And now I'm going to plug the cable for the power source of the light source into the back of the light source, and then plug it into a power outlet. And so the final step is to plug the Ethernet cable into the MV.X. There are two Ethernet ports on the MV.X. The port further from the power supply is set to a static IP, and the port closer to the MV.X is set via DHCP. All right, so now you have initially set up your scaffold and you have your sensor in place and moved all the way up to the position of the stops. So the next step in the alignment procedure is to align your light source that you have just attached and moved so the connection is flush with the edge, which will approximately center your light source on the belt. Now you need to optimize the position of the light source so it is shining right where the line of your imager is looking. So an easy way to do this is to take a piece of paper that will give you a nice big white target and line up one edge of that piece of paper with the scaffolding. So you know that the piece of paper is somewhere under where the imager is looking. And again, now you've got a nice big white target, and as you adjust the light source, you will easily be able to see when it's nice and bright on the imager. So next step, of course, is turn on your light source. There's a power switch back here, and there's also a potentiometer on the front that adjusts the brightness of the light source. I recommend just putting it all the way at high. Of course, you can go from low to high. So for this initial case, we want to have the light as bright as possible. And now you can see that the light source isn't at a good spot on the paper. It's not under the sensor. And on my computer, the image is quite dark. Of course, the other thing you need to make sure to do is to have the live video going. So the live video is going, and you're not seeing much light under the sensor. So as you adjust the tilt of the light source, you will start to see light appear on the sensor, and you'll go through the maximum, and then again back to it, and you will leave the light where you get the optimal brightness. So now, and then it is in general a good idea to tighten the light source even more so it really stays locked in place. And now you've got your line light centered where your sensor is looking, and now you can place your spectral on white target on that line, and again move it back and forth to center the spectral on the belt. And now you've got your bright spectral on target centered under the sensor and on the light source. At this point, you want to adjust the exposure of your sensor to optimize the exposure at about 80% of saturation. So this had already happened already on my screen, but if you just opened up the live view, you would not see the traces at the bottom. So if you click on the live view, you will see the traces come at the bottom, and then you can see how bright it is. And so we want the maximum of these counts to be somewhere around 200, and then you're at about 80% of saturation. So you can go into the camera settings and then adjust the exposure. I'm going to move it up to 6 milliseconds. And now I've got a slightly higher exposure. I think I want it a little bit higher. I'm going to try 7 milliseconds. And this looks to be about the optimal exposure. So now I have set my exposure time as well. And finally, I'm going to take my focus alignment target, which is just a 1 centimeter spaced grid of lines, and I'm going to put it on top of the spectralon. And in my case, I'm going to see that the lines are in nice sharp focus. And so at this point, I can move on and start putting samples under my imager on the belt and start collecting data. If you do not have the lines in nice sharp focus, at this point you would need to remove the cover and adjust the focus of the camera, and now I will go over that as well. So in order to remove the cover, you want to place the retention clips on the MV.X, so when you undo all of the screws, the cover doesn't just fall off. And note that these are all retained screws, so when you screw them all the way out, they will not fall down on the table, and so you just loosen them until they are no longer holding the cover in place. Once all the screws have been loosened, make sure to grab onto the cover and then take off the retention clips and carefully slide the MV.X cover down. Now you have access to the lens and can adjust the focus. Now that you're ready to adjust the focus of your lens, simply loosen the retention collar. And once the retention collar is loose, you can adjust the focus of your lens. And as you adjust the focus of your lens, you will see the lines go in and out of sharpness. So now I'm on one side of the focus, and you can see that my 1 centimeter space lines are not in sharp focus at all. And then as I adjust the focus, you can see them coming more and more into focus. And now I'm going to go to the other side of the focus. So now again, you can see that I've gone through the focus, and your lines are again not in sharp focus. So now I'm going to go back to the optimal location. And once you have the lens at the optimal focus, retighten the retention collar to lock it into place. And then finally, put the MV.X cover back into place as well, using again your handy clips to hold it into place. While you screw the screws back into place. So as you are configuring your MV.X and figuring out how samples are going to be presented to it, one helpful thing to know is the field of view, or the width of view of the camera. Because again, this is a line scan imager, so we are viewing a very skinny line across most of the width of the belt. And you can adjust the width of the belt that is in the field of view by moving the sensor up and down. And of course, if you move it higher up, your field of view will get wider. And if you move it lower down, your field of view will get narrower. If you move the MV.X up or down on the scaffold, you will of course need to readjust the focus so the lens is focused to the proper position again. And also, if you move it closer and so have a narrower field of view, you will increase your spatial resolution. And so there is always an interplay between the spatial resolution and the field of view. But it is often useful to find out exactly how far your field of view extends. So for this particular case, where we have the imager set to the pre-allocated position as dictated by the stops on the scaffold, we get most of the belt in the field of view. And I will demonstrate this by putting a couple of Allen wrenches across the field of view. And so as I move the Allen wrench, I can see the Allen wrench appear on the hyperspectral image when it's blocking my view, and I can move the Allen wrench all the way across the field of view. And so now this Allen wrench will mark approximately one edge of my field of view, and I can put another Allen wrench in here, and this Allen wrench will mark approximately the other side of my field of view. And so now I've found approximately the field of view of my sensor by simply putting an Allen wrench or any other narrow object in front of the sensor to block a little bit of the white reference light being reflected back up. Hello, my name is William Rock, and I'm an applications engineer at Headwell Photonics, and today I'm going to talk to you a bit about the web UI for the MV.X sensor. First, I'm going to run down all of the different function tabs here one by one, so you get an idea of how to use the MV.X web UI. The first setting tab is the camera settings that you use to set the exposure, the frame period, the region of interest, and the gain. So the exposure and frame period we've already played with a little bit when we were setting up the light source and optimizing some things there. And so I'm just going to go back and cover that one more time. So first, I'm going to start the live view, where I can see that I have my white spectralon tile under the sensor, and I'm getting a nice bright white response. And if I click on the brightest area of the image, I can see a trace on both the spectral dimension and the spatial dimension of that of the sensor. And this allows me to see whether or not I've optimized the exposure properly. And the exposure and the frame period can be set independently of one another. And this allows you, because the frame period is the important parameter when you are trying to set the speed of the detector or the speed of the belt in order to acquire square pixels. And so if the frame period doesn't move, then your belt speed for square pixels will remain constant. So in this case, I'm going to leave the frame period constant, and I'm going to adjust the exposure. If I make the exposure time smaller, of course, the image will get dimmer. And I want to adjust the exposure time until I'm at about 80% saturation. And so that setting was about at 6 milliseconds, which as you can see is maxing out at just above 200 counts, which is about 80% of saturation. Now that I have set the exposure time, I want to move on and collect white and dark references. So a white and dark reference need to be collected every time you change either the frame period or the exposure time, or anytime you adjust the light source, because it's how you tell the sensor how bright the light is hitting the sample, and also how much camera response there is for that light. And so now that I have my camera settings finished, I can click Collect Dark Reference, at which point a shutter will close and the dark reference will be collected. And then I will click Collect White Reference. Of course, make sure that your spectral on tile is in place and reflecting light everywhere in your scene to collect a full frame white reference. And now you see that I get a blue check mark after I've collected both the dark and white reference. And these are reminders that it has been a while since the last time you've collected a reference. It is also good practice to collect a new reference at least daily to make sure you're adjusting for any possible illumination drift that could happen over time. The next tab is the Acquisition tab, where you can set the spatial and spectral binning and also adjust the output, the GeniCam output. And so there are 4 options in the GeniCam output. The raw hyperspectral, which gives you the image that you're seeing up here, which is just the raw digital numbers coming off of the imaging spectrometer. The classified color, the classified grayscale, and the classified index. All of the classified outputs, of course, require you to have uploaded a model. And once you've uploaded a model, you can output the RGB image of that model in classified color. You can output a grayscale rendering of that RGB image in classified grayscale, or you can output classified index, which is the classified index means that for each different class you're getting a 1, a 2, or a 3, and it goes sequentially. So everywhere where you have the first class, you will see a 1, the second class you'll see a 2, etc., and it is indexed. The next tab is the Classification tab that you can use to both upload classification models and collect training data to be used to generate classification models. And you can also see all of the models that have previously been uploaded. You can see that I have preloaded a colored blocks classification model on this particular unit. So in order to collect training data, you click on the Collect Training Data heading, and then you can give a useful prefix or suffix to your data folder. And every data folder will also be appended with a timestamp. So you will never overwrite any data, but if you forget to put a prefix or suffix, you will only have a timestamp to identify your sample. In this particular case, I am going to measure some colored blocks. And so I'm adding a colored blocks prefix. And now I will start my stage, and after I've started the stage, I will hit Start Capture. And once my blocks have passed by my imager, I will hit Stop Capture, and I will only collect data in between the Start and Stop Capture buttons. So now you see my blocks coming on the screen, and after they passed by, I hit Stop Capture, and this was a rather small image, so it didn't take much time to collect it. And after I've collected the data, I can go into the next tab, which is the Data Manager tab, where all of the data that is currently stored on the internal hard drive of the MV.X can be found. And so now I can go down here and I can see that a couple days ago I collected some other colored blocks data, and today I collected a new set of colored blocks data. And if I click on the little arrow here, I can expand the folder and see what's there. I have a dark reference and a white reference. The most recently acquired white and dark reference will always be added to the data folder along with the raw data. And this data is called raw 0, which means that the first frame in this data is frame 0. And if you have something that's, say, raw 1000 in there, that will mean that the first frame in that particular data cube is the 1000th frame. And so now I want to download this entire folder, so I will select the folder and I will click export. And all of the data will be exported to my downloads folder. And I want to click yes, that I will allow multiple files to be downloaded from this IP address. And so now all of the files are being downloaded to my downloads folder. And after I've downloaded all the files to the downloads folder, I would like to generate a model using per class using that data. So the first step that I will do is move all of the data from the downloads folder into a better location. So I'm just going to create a new folder on the desktop, and I'm going to call it colored blocks. And so now I have put all of my colored blocks data into the colored blocks folder. And at this point, I'm going to open per class Mira. This is the icon for per class Mira that is in my toolbar below. And so I will open per class. I want to select a head wall data type, and I also want to tell it what top level data directory to find my data in. So here I'm going to click the browse button. I put my data on the desktop. So I'm going to select the colored blocks image or data folder and select the folder and then press OK. Now I have a blank per class Mira project with no images loaded, but I'm going to start in the data folder where I just put all my data because that's where I told it to start. And so now if I right click on the images, I can click add image to project. It will start in the project folder, and I will select raw 0 dot header. And now my colored blocks have been added as an image, and I can adjust the scaling of my image by moving the scale up and down here, and I can adjust which bands are used for red, green, and blue by dragging these red, green, and blue bars here. And so I'm going to put them in reasonable locations for red, green, and blue colors. So now you can see the blocks in true color. Now I want to start creating a model. And I create a model by adding different classes in this class area of per class Mira. So I'm going to right click there and I'm going to hit new class. And the first class that I always add is the background, because you always need to define the background in your image so you can tell per class what area is the background is the uninteresting part of your scene going to look like. And so then in order to define any class, you just draw around the scene a little bit. And so here I drew around in a couple places, and now I've defined the background. And I can also make the background any color that I want, and I can make any of my classes any color that I want. So say I want to make the background white. When I make the background white, the color of my painting changed, and now when I create a false color image, that background will be white within Mira. So now I will create a different class for each of the blocks. Let's start first with blue block. And I will make the blue block blue. And now I will color on my blue blocks to tell Mira which spectra to make a blue block. Then I will make a pink block class. Again, I can make my pink blocks pink, and I can draw on them. Next, I will make a red block class. Again, make it red. And finally, I will make a green block class. I will color on the green blocks, and then I will change it to a more appropriate color. Now finally, once I've done all of my training, I can hit model search up here, and you can see down in this lower right hand corner that it is executing the model search, and when it is done, it will automatically display the decisions image, where now you have you can see the decisions that Mira has made of the different colored blocks, and so you can see that all of the blocks have been identified pretty well. There are other more advanced functions in per class, but that is currently beyond the scope of this quick tutorial to just get you up and running, generate a simple model, and upload that model into the web UI. So now I'm going to move right into generating a model for the web UI, and in a subsequent video I will talk more about the advanced functionality of per class. So in order to generate a runtime engine, you go to Export Classifier Pipeline, and then pick the top option, Per Class Mira Runtime. And then it will ask you what folder you want to put that in and what you want to call it. So this is a colored blocks model, so I will call this colored blocks model, and I will save. And now if I minimize Mira and go back to my folder, I have a colored blocks model.mpl in my downloads folder. So now I can go back to the web UI, go back to my classification tab again, and I can upload a model. And then I can go to the folder that I was just at, which is on the desktop, colored blocks, and I can upload colored blocks model.mpl. Today I'm not going to upload that because I already have a model there. And once I have uploaded the model, I can select the model. So I'm going to select this colored blocks model. And this is what I'm going to use to display the imagery. And once I have a model uploaded, I can select the classified option on the display. And now you can see that a classified pseudo color image will be generated. You may notice that the colors do not match exactly with the per class colors. That is because the web UI will automatically generate yellow for the background or the first class, and then other classes will have automatic colors picked for them, so it won't be the same colors that you've selected before. But if I start my belt again and move my colored blocks past the imager, you will be able to see them appear as false color images on the scene. Again, the colors are a little mismatched, but all of the images, or all of the blocks are being classified via a pseudo color image, and you can see the pseudo color image being generated with a yellow background. Finally, I'm going to briefly go over the networks setting tab. So currently I have the MV.X plugged in using a static IP on the computer that I'm connected to right now, and I have it also plugged into our local area network here at Headwall's headquarters. And so when the MV.X comes out of the box, it will be configured with the static IP in port 1, 10.0.65.50. And as you can see, when I select port 1, that static IP address is selected. I can manually change that if I want a different static IP address, so you can do that as well. And if you want to find the dynamic IP address of the MV.X on your local network, you can go to Ethernet 1 or port 2, and it will display the dynamic IP address on your particular network. Here at head wall, the dynamic IP address is 192.168.77.119. And so that is the way that you can figure out the DHCP address on your network locally. I will also note at this time, please do not change the method from static to dynamic on port 1 or Ethernet 0, because that could lock you out of the MV.X temporarily until Headwall is able to reconfigure your IP.